In our study of limits so far, we have come up with 4 ways to evaluate a limit: numerically, graphically, substitution, and then cancel a common factor. So now let's look at a 5th way. And this is going to be creating and canceling a common factor. So let's look at this example. We want to evaluate the limit as x approaches 0 of the square root of 3 plus x minus the square root of 3 all over x. Alright, so we substitute in 0. We always want to try that. And it's indeterminate. So we've got to come up with another way to evaluate this. Now, numerically isn't necessarily a bad idea, but that does take time, and if you don't have a calculator, it doesn't work. And I mean, to kind of put this in perspective too, a lot of this developing our limits is really to help us develop calculus, so we're kind of going through techniques that we're going to use later on in calculus. But anyways, we try to cancel a common factor, but we look at this and we realize, well, we can't factor that. So the next thing we're going to try is we're going to create and then cancel a common factor. Okay, the key to this is we're going to multiply by the conjugate. Okay. So we have the limit as x approaches 0 of the square root of 3 plus x minus the square root of 3 all over x. Now I'm going to give you guys a hint. Anytime you see these square roots, well, it's not always going to happen, but that's usually when I kind of look at this and realize that I'm going to have to create and cancel a common factor. This is just a common one that's used when we end up having these radicals in the problem. So we have these radicals, and we're going to multiply by the conjugate. And the conjugate is, of course, of this kind of binomial part. So we're going to multiply by the square root of 3 plus x plus the square root of 3 all over the square root of 3 plus x plus the square root of 3. Alright, so let's see what we end up here. Alright, so we're going to have the square root of 3 plus x times the square root of 3 plus x. Wait, I'll write the limit as x approaches 0. So we're going to end up with the square root of 3 plus x squared. Then we're going to have the square root of 3 plus x times the square root of 3. So we're going to end up with a plus square root of 3 times the square root of 3 plus x. Negative square root of 3 times the square root of 3 plus x is minus the square root of 3 times the square root of 3 plus x. And then a negative square root of 3 times a positive square root of 3 is a negative square root of 3 squared. All right. Now x times all this, you know what? Through experience I have learned, let's just go ahead and 3 plus x plus the square root of 3. I'm not going to multiply that through. I'm not going to distribute that x yet. Just, you know, from experience, a lot of times this is going to get canceled out anyway, so if we multiply it out, we would just have to refactor it. All right, right now, you look at this and you really think, gosh, this is more complicated than what we had before. But some nice things do happen. Notice that these middle terms cancel out. And that's the whole idea. The conjugate is you end up canceling out the middle terms. And notice that the outside terms, well, those are being squared. So we end up with the limit as x approaches 0 of 3 plus x minus 3 all over x times the square root of 3 plus x plus the square root of 3. Alright, so these 3's cancel out, so we get the limit as x approaches 0 of x all over x times the square root of 3 plus x plus the square root of 3. Alright, now this is the point where we're looking at this and we figure out whether or not this is going to work. Because, if you remember, the original problem we had was the fact that there was an x down here. So when we put in the 0, it was dividing by 0. Well, notice that after creating and multiplying by the conjugate, we end up with an x in the numerator that we can cancel out with the denominator. And so this is going to equal the limit as x approaches 0 of 1 all over the square root of 3 plus x plus the square root of 3. Now we can go back to our original, or back a couple steps, the substitution. And so we end up with 1 over the square root of 3 plus 0 plus the square root of 3, which ends up being 1 over 2 times the square root of 3. And there is our answer. So there is technique number 5, creating and canceling a common factor. The key to creating and canceling a common factor is to multiply by the conjugate, and as a hint, if you ever see radicals and you're looking at realizing you can't factor it, then this is probably the technique you're going to have to use.